Every star you have ever seen is living on borrowed time. The calm, steady glow of the night sky is an illusion, one that hides a violent truth. Stars are not eternal beacons of peace. They are massive nuclear engines, locked in a constant battle against their own gravity, burning through their lives with quiet determination or explosive rage. And when that battle ends, the universe does not whisper. It screams. The death of a star is not a single event. It is a transformation, a rebirth through destruction, a moment when the universe reminds us that creation and annihilation are not opposites, but partners in an endless cosmic cycle. To understand how stars die, we must first understand how they live. A star is born when gravity wins. In the cold darkness of space, vast clouds of gas and dust drift for millions of years. These clouds are fragile, easily disturbed. A passing shockwave from a nearby supernova, the collision of galaxies, or even a subtle gravitational nudge can cause a region of the cloud to collapse inward. As it contracts, it heats up. Pressure rises. At the center, temperatures climb into the millions of degrees. Then suddenly fusion ignites. Hydrogen atoms fuse into helium, releasing enormous amounts of energy. That energy pushes outward, balancing the inward pull of gravity. This delicate equilibrium, pressure versus gravity, is what allows a star to exist at all. As long as this balance holds, the star lives. For small stars like red dwarfs, this balance can last for trillions of years. They burn their fuel slowly, patiently, barely changing over timescales longer than the current age of the universe. They will outlive galaxies. But for massive stars, true giants of the cosmos, life is brief and brutal. These stars burn hotter, faster, and brighter. They consume their hydrogen in mere millions of years. And when hydrogen runs out, gravity begins to tighten its grip. The star does not simply shut off. It fights back. As the core contracts, temperatures rise enough to fuse helium into heavier elements, carbon and oxygen. When helium is exhausted, the core contracts again, igniting carbon fusion. Then neon, then oxygen, then silicon. Each stage burns faster than the last. What took millions of years now takes thousands, then years, then days. At the center of the star, a layered structure forms, like an onion, each shell fusing a heavier element than the one above it. This continues until iron appears in the core. And iron is death. Fusing iron does not release energy. It consumes it. When a star begins producing iron, it has reached a dead end. There is no new fuel to push back against gravity. The balance collapses. In less than a second, the core implodes. Protons and electrons are crushed together, forming neutrons. The core collapses at a significant fraction of the speed of light, shrinking from a region larger than Earth to something barely the size of a city. Then suddenly the collapse halts. The core becomes incompressible, and the outer layers, still falling inward, slam into it. The result is one of the most violent events in the universe. A supernova. The star explodes with the power of billions of suns, releasing more energy in a few seconds than our sun will emit in its entire lifetime. For a brief moment, the supernova can outshine an entire galaxy. Shockwaves tear through space, blasting stellar material outward at tens of thousands of kilometers per second. In that instant, the universe becomes an alchemist. Elements heavier than iron, gold, uranium, platinum, are forged in the inferno of the explosion. Every atom of gold in your jewelry, every trace of iodine in your body, every heavy element on Earth was born in the death of a star. Supernovae are not just endings, they are beginnings. Their shockwaves compress nearby gas clouds, triggering the birth of new stars. Their debris seeds planets with the chemistry needed for life. Without supernovae, the universe would be chemically simple, dark, and sterile. But the story does not end with the explosion. What remains at the center of a dead star depends entirely on its mass. If the star was massive, but not too massive, the collapsed core becomes a neutron star. A neutron star is one of the strangest objects in existence. It packs more mass than the sun into a sphere only about 20 kilometers across. A single teaspoon of neutron star material would weigh billions of tons on Earth. Its gravity is so intense that it warps space itself. These objects spin at incredible speeds, sometimes hundreds of times per second, and emit beams of radiation from their magnetic poles. If those beams sweep past Earth, we detect them as pulsars, cosmic lighthouses blinking with machine-like precision. Neutron stars are stellar corpses, but they are far from quiet. They crack and quake. Their magnetic fields are trillions of times stronger than Earth's. They can strip atoms apart from a distance and distort the very structure of matter. But if the star was even more massive, the outcome is darker. If the core exceeds a certain limit, not even neutron pressure can resist gravity. The collapse continues. Space folds inward. A black hole is born. A black hole is not an object in the traditional sense. It is a region where gravity becomes absolute. Beyond the event horizon, space and time trade roles. All possible paths lead inward. The future points toward the center. Nothing escapes. Not light, not matter, not information as far as we know. From the outside, a black hole appears deceptively simple, defined only by mass, charge, and spin. But inside, our understanding breaks down completely. The laws of physics tear themselves apart at the singularity. Black holes are the ultimate stellar graves, but they are also architects of galaxies. At the centers of nearly all large galaxies, including our own Milky Way, lie supermassive black holes, millions or billions of times the mass of the Sun. These monsters grew from the deaths of early stars and the mergers of smaller black holes. Far from being mere destroyers, they shaped galaxies. Their gravitational influence controls star formation. Their energetic jets regulate the growth of cosmic structures. Galaxies are not just collections of stars. They are cemeteries. Every galaxy is a graveyard filled with stellar remains. White dwarfs, neutron stars, black holes. Each one a reminder that nothing, not even suns, lives forever. And yet, even in death, stars leave echoes. Supernova remnants expand for tens of thousands of years, glowing in X-rays and radio waves. Nebulae formed from stellar debris become nurseries for new generations of stars. The universe recycles its dead with ruthless efficiency. Even our own sun will one day die. It will not explode in a supernova. It is not massive enough. Instead, in about 5 billion years, it will swell into a red giant, consuming the inner planets. Earth may be incinerated or stripped down to a lifeless core. Then, the sun will shed its outer layers, creating a planetary nebula, a glowing shell of gas drifting into space. What remains will be a white dwarf, a dense, cooling ember of a once living star. Silent, fading, a cosmic tombstone. If the universe teaches us anything through the death of stars, it is this: permanence is an illusion. Everything that shines will fade. Everything that forms will break apart. But from those endings come new beginnings. You are here because stars died before you were born. Your atoms passed through furnaces hotter than imagination, were scattered across space, and eventually assembled into a being capable of understanding where it came from. In that sense, you're not just observing the universe. You are the universe, remembering itself. This is the mystery explored by World's 1001 Mysteries, the hidden lives and violent deaths of the objects that make existence possible. If this journey through stellar death gave you a new sense of perspective, share your thoughts below. Do supernovae terrify you, or do they inspire you? Like the video, subscribe to World's 1001 Mysteries, and turn on notifications for our next descent into the unknown. Until then, remember, the stars are dying, so that we may live.